Confirm.
Perfect, thank you. And can I also confirm that you are able to see the screen, which is this worksheet? All good. Okay, perfect. Thank you. All right, so we're going to go ahead and get started. Once again, good evening to everyone. I hope you're all doing well. So today we're looking at the Learning Unit 9 content. So this is the last learning unit of the module, which I'm sure you're ecstatic to hear. I'm hoping that the past week has given everyone a chance to catch up with everything up until this point. Obviously, it is a bit much to just, consistently go at it and cover learning unit after learning unit. So I want to just take a bit of time off here and there to give you a chance to catch up and, be on par with everything because it obviously is a lot to take in, especially these last four learning units. It can get a bit much. It is a lot of content. It is a lot of statistics as opposed to your normal mathematic type questions. So I just wanted to give you some time to catch a breath and just get on the same page so that we are good to go for the last learning unit. So, this is a nice learning unit in the sense that it is quite a straightforward one once you have gone through the process. It's actually the same 5 steps as the previous learning unit, which I will reiterate in a second. So the learning unit is called chi-squared testing. So I'm just going to write that up on the screen. And it is actually one of the easier learning units, and it actually is easier than learning unit 8. So it's chi-squared testing, or you can call it a chi-squared distribution. And it is, as I said, the same 5 steps that we saw in Learning Unit 8. So that's quite nice because it's a bit repetitive in that sense. And we also work with statistical tables here. You'll see that it's the third statistical table in the tables that will be given to you in at the end of your formula sheet. And then it's quite a nice section because it really doesn't go beyond the type of questions that we'll be going through between today's lecture and next Wednesday's lecture. So it's quite repetitive. The same type of thing can be asked over and over again. It's also nice because as opposed to learning unit 8 where there were 3 types of hypothesis tests that could take place, here there is only one type of test. So if you recall from your learning unit 8 content, we could either have a two-tail test or we could have a one-sided upper tail test or a one-sided lower tail test. The nice thing about learning unit 9 is it can only be one-sided upper tailed. So you don't have to worry about the possibility of it ever being a two-sided or a one-sided lower tail test. So that's quite nice because it sort of eliminates some of the work that we would need to do. And we know the type of test, definitely a one sided upper. And then that also makes it easier when we get to step 2 of the process where we need to draw up the bell shaped curve and so on. So it's a nice learning unit. It's an easier learning unit than learning unit 8. It is the choice, remember, once again, as I had mentioned to you a couple of times throughout the semester, this module has options in the exam. So in section D of your exam, you generally have the choice between the learning unit 8 content and learning unit 9. And I have advised, I always do say to students that between the two, the easier is learning unit 9, and it is one that you will score better in as opposed to learning unit 8. However, if you feel comfortable with learning unit 8 as opposed to learning unit 9, that's perfectly fine as well. You're obviously not restricted to choosing learning unit 9, but it just is one of the easier learning units as opposed to learning unit 8. So today we're going to go through, just reiterate what the steps are in terms of your chi-square distribution. It's the same 5 steps, exactly the same 5 steps as hypothesis testing. So it's not going to be any new knowledge there. And we're going to look at the 2 examples that you see up on the screen, and then we'll go through more examples next week. So I'm just going to do 2 for today, and again, probably 2 next week. But I just want to do these 2 today so that we can look at an introduction of the learning unit, how to apply the 5 steps. And once we do the first 2 after today, you'll see that you'll obviously be able to see that it is a bit easier than the learning unit 8 content. And then also it's exactly the same thing over and over again. So it's nice in the sense where there's no, you know, tricky questions that they can give to you, or difficult ways that they can ask you this question. It's a standard type of question in terms of, it's one-sided upper tailed. This is the type of questions that they can ask, and that's it. There's no possibility of trying to figure out from the question, is it a one-sided upper tailed, or one-sided lower tailed, or is it a two-sided? And then when it's a one-sided or two-sided, do I have to use a value from table 1 of the appendix, or do I need to go to table 2 of the appendix, or do I need to go to the table from the slides, that kind of thing. So with hypothesis testing, it obviously is a little bit tricky, because hypothesis testing is a question where you sort of have to, really separate things, and then use certain things to identify certain aspects of the calculation. And then if that's not correct, it sort of affects the next step of the calculation, and it has a bit of a domino effect. So that's a little bit of a downside when it comes to learning unit 8, because if you're obviously identifying it as the wrong type of test, then you're using the wrong critical value, then you're calculating and creating an incorrect conclusion, and it's sort of just, the whole thing then just goes wrong. So the nice thing, as I said, about this learning unit is you're never going to have to worry about identifying, am I working with this type of test, or am I working with this type of test? It's never a decision about, is it two-tailed, is it one-sided, am I using a Z value, am I using a T value, am I using this table, am I using that table? It's pretty standard. So this is, as I said, the easier of the 2. So we're going to look at how to carry out the steps of chi-square testing. And I'm going to write down those 5 steps again. As I said, it is the same 5 steps as we had seen in hypothesis testing, but it's just that obviously we apply it now specifically to a chi-square test. So the first step is always to state your hypotheses. Remember, you always have a null hypothesis and an alternate hypothesis. Then you have the second step as being determining your region of acceptance and rejection. So determine the region of acceptance and rejection. Then you calculate your test statistic. And in this learning unit, the test statistic is called the chi-squared test statistic. So I'm going to say this, and I'll explain to you in a second that symbol. Then the 4th step is to compare your test statistic to the region of acceptance and rejection. I'm just going to say to the region of acceptance here because I don't want it to become too cramped. And then the 5th step, is to conclude. Okay, so these are the exact 5 steps as hypothesis testing, but we are going to now make it specific to your chi-square test, where we would have, for example, the wording of the hypothesis itself are different. Your type of test is limited to a one-sided upper tailed. The way you calculate your test statistic is different. And then the second last and the last step are pretty much the same. So there's no real difference here from hypothesis testing. So let's get started with that. So when it comes to a chi-square test, firstly, you are either dealing with a test of independence of association, or you're dealing with an equality of proportions test. Now, this is something that you can read about in a lot more detail in your slides, but I'm just going to point it out here because we do find that this affects your hypotheses. So I'm going to write it down at the top here. You will either have a test of independence. It's generally called a test of independence of association. Or you have a test of equality. And this is usually referred to as a test of equality of proportions. Now, this type of test that I'm mentioning at the top here, independence or equality of proportions, only affects step one here, your hypotheses. It does not affect anything else except for step one, because it literally is only going to affect the way we write out your null and alternate hypotheses. So if it's a test of independence of association, all that means is we are trying to test whether two variables are independent or are they dependent on each other. Now, with chi-square testing, the test is all about testing for patterns. We basically want to know, is there some sort of pattern or trend that we can pick up between our variables? And this is different to hypothesis testing, because hypothesis testing was about testing the validity of a claim, meaning a claim was being made and we want to know, is that claim true or is it false? So how valid is a claim that is being made? Now, as I said here with chi-square testing, we're trying to test what kind of pattern, if any, exists between two variables, or if there's a trend that we can identify, what sort of trend is there. So it's just about identifying patterns and trends or relationships that exist between your variables. Now, the first one, as I said, which is an independence of association test, is just looking at, are two variables dependent on each other somehow, or are they completely independent of each other? So when we write out your null and alternate hypotheses, the lovely thing about this learning unit is that you do not need to use symbols. You will just write it out as a normal sentence. So when it's a test of independence of association, your null hypothesis, and I'm just going to write it at the top here because I want to be able to show you both the test of independence and equality. So the test of independence must always say in the null hypothesis that the two variables are independent of each other. So I'm just going to write the word independent for now because we'll obviously write it out in a full sentence when we get to the example. And then your alternate must say that there is some sort of dependency between the variables. Now, this will never ever change. You can never swap them around. The null will never say that there is dependence between the variables, and the alternate can never say that the two variables are independent of each other. It must be in the sequence that I've written here. The null hypothesis must always say that the two variables are independent of each other. Or you can even say, instead of saying independent, if you want, you can say that there is no relationship between the variables. Or you can even say that there is no statistical association between them. So any one of these words can be used. You can say that the two variables are independent of each other, or you can say there is no statistical association between the variables, or you can say that there is no relationship between the variables. And as always, because the null and alternate are opposites to each other, whatever the null says, the alternate must say the opposite. So the opposite will say either that the two variables are dependent on each other, or that there is a relationship between the two variables, or that there is a statistical association between the two variables. So I'm just going to show you if we did say that there is dependence, then we could say this. So you could say that they are dependent, or that there is a relationship, or you could say that there is statistical association between the two variables. Okay, so this is always the case for a test of independence. And you'll see in the questions just now, they will tell you what they're looking for in a particular test. So you will be able to identify that it is a test of independence, or am I working with the test of equality? Okay, so for example, just to show you what we mean by that, if you look at this specific question on the screen now, this part that I'm highlighting, from the question, it says determine whether there is a relationship between gender and the preferred insurance provider. So literally from that, you know that it's a test of whether there's a relationship or not, or whether it is dependent or independent. So you know immediately from that that we are working with a test of independence. Now for your other one, which is a test of equality. So a test of equality also, in exactly the same way, will only be written in words for the null hypothesis, no symbols needed. The entire test, whether you're dealing with independence, whether you're dealing with equality, you are never having to show symbols in your null and alternate hypotheses. So for a test of equality of proportions, your null hypothesis must always say that they are equal, that the two variables are equal in the null, and your alternate will always say the opposite. So it will say that they are not equal. Or you could even say, instead of the word equal, you could say that they are the same in the null, and the alternate could say that they are not the same. So with an equality of proportions test, your question will basically also say to you or give you an indication that it is an equality test. So if you look at question 2 at the bottom here, again, just to show you that you will be able to tell what type of test it is, it says test whether the soaps are equally popular. So immediately from that already, you've seen that this says to you they've literally used the word equal or equally, and this means that you're dealing with a test of equality of proportions. So now we know that your null hypothesis must always say that they are equal, the two variables are equal, or that, like you saw just now, there is equality, or that they are the same, and the alternate must say the opposite, so it will be that they are not the same. So that is the difference between your independence test and your equality test. And that's literally only going to be in step 1. It does not affect anything else. Then you need to determine in step 2 now your region of acceptance or rejection. So now with step 2, you are only ever going to have a two-tailed test. So a two-tailed test, sorry, I'm just going to erase here. Sorry, you're only going to have a one-sided upper tail test. It's never going to be a two-tail test. So here, and I'm just going to draw it in the middle here. Actually, let me draw it here, just above it. So it's only ever going to be a one-sided upper tail test. And an upper tail test, when you draw the bell-shaped curve up, only has one limit on the right-hand side. And this value, this critical limit, is always a positive value. It's never going to be a negative value. And everything, including that critical limit and less than it, is your region of acceptance. Everything greater than it is your region of rejection. And that is your diagram. That is your region of acceptance and rejection. Now for the actual value that goes in here, your critical limit. Now for the critical limit, you need two things. You need something called a level of significance, which we also did see in Learning Unit 8. So that's the letter A that denotes a level of significance. And then here, the other thing you need, and remember, level of significance, sorry, before we move on, could only ever be 1%, or it could be 5%, or it could be 10%. It can never be anything else. Okay, then the other thing that you need is something called a degrees of freedom. So I'm going to write that at the top here. It's denoted by the letters DF. So it's degrees of freedom. Now, a degrees of freedom is calculated in two ways, depending on the type of table that you have. If you have a table that looks like this two-way contingency table that you see up here, then the degrees of freedom is calculated as the number of rows minus 1 multiplied by the number of columns minus 1. Now, the rows and columns that we're talking about here is only the rows and columns that have the actual information or of that category, basically. So it is the rows that have the categories. So, for example, here it's two categories, male and female. So that's two rows. So 2 minus 1. And then at the top here, your columns have three categories. So momentum, liberty, and discovery. So that would be 3 minus 1. So whenever you have a table that looks like this, then you will have the degrees of freedom calculated as R minus 1 multiplied by C minus 1. And then the other way that you can calculate the degrees of freedom is if you have information that is trying to scroll. Okay, there we go. So when you have information that is presented like this, where it's not a two-way table, it's just a normal table, or even if it wasn't in table format and it was just like a paragraph of information, then it would be calculated as n minus 1. And n here just means how many categories do you have. So for example, here there's three categories and or how many variables you have basically. So it would be 3 minus 1. So there are two ways that you can calculate a degrees of freedom. It is either R minus 1 multiplied by C minus 1, or it would be N minus 1. So it just depends on the type of information that you have, and that would affect your calculation of your degree of freedom. So for now, we're not going to go into it just yet because I obviously need to do the example. So I'm going to say it's either that one or this one. Okay, so we'll do the example just now and we'll obviously put that into play with both those questions. But just so you know, there are two ways a degree of freedom can be calculated. And it is either, if it's a two-way table, then it's R minus 1 times C minus 1. And then if it's not a two-way table, basically, then it's N minus 1. Now, once you have that value of A and your degree of freedom, you're going to go to table 3 of your appendix, which I will show you just now. And this table 3 is your chi-squared table. It's basically showing you all of your respective factors for a chi-squared distribution. So I will show it to you just now when we're working with the examples itself. For now, let's just look at the steps. So once you have the figures for your A and your degrees of freedom, you're simply going to go to table 3, and it's actually quite straightforward. It's very, very similar to the T table we worked with in Learning Unit 8. So all you do is you locate A going across and your degrees of freedom coming down the first column. That's literally it. There is nothing else to it. And using A and your degrees of freedom, you will get to your critical value. Okay, so that's your region of acceptance and rejection. Now for the third step. This is to calculate your test statistic. Now, to calculate your test statistic, I'm not going to be able to explain it right now because I would need the table and the information to show you how to calculate that. So I'm going to leave that step out for now, and that I will show you when we look at both the examples here. And then the fourth step is to compare your test statistics. So whatever answer you get from question 3 here, you compare it to your region of acceptance and rejection and see where your test statistic falls. And then using that, you'll be able to determine whether you're accepting or rejecting the null hypothesis. And this is what you then use to conclude. So remember, in your conclusion, you must either say you accept the null or you reject the null. And then don't forget, you need to elaborate. So you need to state what you actually mean when you say that you accept or reject the null hypothesis. Okay, so now that you're more or less familiar with the steps, let's get to the example so we can look at mainly step 3, which is to calculate the test statistic, but obviously all 5 steps because we do need to carry out all 5 steps, but just to mainly be able to show you how the different ways that information is provided will affect the way in which you calculate your test statistic. So these 2 questions are typical test questions or assessment questions. They are from a past assessment, and they are literally exactly the type of question that you can expect in your exam. And generally, they go for anywhere between 8 to 12 marks, just depending on how quick or how long a question is. So generally, the one that you see on the screen at the moment is about 12 marks. Again, though, it can go for about 8 marks. So sometimes when you're not required to do as much work, like the next question, then that would be for about 8 marks. Sometimes 7 may be possible, but the general mark allocation is from 8 to 12. So this says to you, we wish to determine whether there is a relationship between gender and the preferred insurance provider. So, as I said, here you are literally told that you are trying to test whether there is a relationship. So, this itself is basically saying to you that you have a test of independence of association here, or you're testing whether there is a relationship or not. So, immediately, even before looking at the question, you could have immediately written down that this is your null and your alternate hypotheses. Your null hypothesis will always say that there is no relationship or that there is independence between the variables, or you can just say there's no statistical association. So your null, I'm actually going to write that out immediately. You can say that there is no relationship between gender and, actually, let me just put in the and sign there to save some space. The preferred insurance provider. And you can see that the information actually gave you the null and alternate hypothesis. You don't even need to think about what to put in here because that first sentence literally told you what you would need to write in your null and alternate hypotheses. So this would say that there is a relationship between gender and the preferred insurance provider. So again, this is one of the nice things about this learning unit. It literally is so straightforward in the sense that you don't have to do so much, inquiries or looking into and trying to figure out what type of test and what keywords am I looking for and so on. You can honestly just look at the information and be able to tell from some of the things that they mention that this is what we are working with. Okay, so that is step 1 done and dusted. It's as simple as that. We know what type of test we're working with, and now we can move on to the rest of the information and then the rest of the steps. So they said to you that they had surveyed 300 South Africans, and these were the results. So you have your table here then that gives you the information. Remember, it's a two-way table. They've given you the information, And you know then immediately that there are 2 rows and 3 columns. So I'm just going to write that out here. In fact, let me just write that out here. C is equal to 3. So 3 columns with the categories and 2 rows with the categories. Then it says to you perform an appropriate test at a 1% level of significance. So I'm again going to say and write down here that your level of significance is 0.01, which is 1% as a decimal. Remember, always convert your level of significance to a decimal because the tables have the levels of significance as a decimal. So you're not going to find it as a 1%. You're going to see the decimal equivalent. So you have your A value, and then they say to you, use this to determine whether there is a relationship between gender and the preferred insurance provider. And again, now that told us what the actual question was and what the hypotheses were. So we've done step 1. Again, as I said at the top, we wrote out immediately that this is the type of test or what we're looking for here, whether there is a relationship between gender and the preferred insurance provider. And then your alternate will say that, well, your null will say that there is no relationship, and your alternate will say that there is one. So when we're done with step 1, we can move on to step 2. Step 2, remember, is to draw up your null and alternate hypotheses. Sorry, to draw up your region of acceptance and rejection. I just want to make this. And we know that everything less than or equal to that line is your region of acceptance. Everything greater than it is your region of rejection. Now for the actual critical value. You have A, you know that it's 1%, which is 0.01 as a decimal. Now you need your degrees of freedom. And we said with a two-way contingency table, it is the number of rows minus 1 multiplied by the number of columns minus 1. So that's 2 minus 1, which is 1, multiplied by 3 minus 1, which is 2. So 1 times 2 gives you a degree of freedom of 2. Now, we need to then take this to table 3 of your appendix, which I'm going to show you in a second. You don't need to write down this table 3 part that I'm writing down here. This is just to show you, obviously. But you do need to write down the value of A and the degree of freedom because there are naturally marks allocated to that. So let's now have a look at your, sorry, I just want to open it for you. Tables. So here is your table 3. Now, table 3 is obviously going to be included in your, actually, sorry, I don't want to open it anywhere else because it's going to close out our document. So table 3 is going to be included in your formula sheet. There are always going to be 3 tables in your formula sheet, table 1, 2, and 3. You only need table 3 for your chi-square distributions. It's literally called the chi-square distribution, as you can see at the top. So here, you're going to look for, I just want to see how I can write on this without closing the other document. I don't think I'm going to be able to, so I'm probably going to have to open that one again. Okay, let's try opening it here. I'm not sure if this is going to work, but I am going to try. No. No, that's not going to work. I just don't want the other document to stop and not allow me to write. So I'm just seeing where else I can open this. Let's try freeform. Okay, nothing's happening there. Ugh, no, it's not working. Okay, so I guess I'm just going to have to open it here and then I'll just go back to that worksheet just now. Okay, so here we go with this one. So we said that A is 0.01 and your degrees of freedom we determined was 2. So all you have to do is, remember I said to you, A is located going across, the degrees of freedom is down the first column. So here is 0.01 going across, and then here is 2 coming down the first column, and in line with the 0.01 and the 2, you have 9.210. And that would be the value now that goes into, remember we had that diagram drawn up and your critical limit, that would be 9.210. So it's exactly the same way that we would look at your values. Let's open that up again. Oh, yay, it saved that work. Okay, cool. So let's look at that on the diagram. So that's 9.210. So all we're going to do now is write this out in words in exactly the same way that we did with Learning Unit 8. We draw up the diagram because it's going to help us visualize, but the mark allocation actually comes from writing that out in words. So we only need to say here, accept the null hypothesis, and this wording will never change. So you can literally learn this off by heart to write down as your region of acceptance and rejection. So you'll say accept the null hypothesis if the chi-squared statistic is, and remember your acceptance region is here. It is everything less than or equal to. So you'll say less than or equal to the 9.210, and you will reject the null hypothesis if the chi-squared statistic now is in the opposite direction. So if it is greater than 9.210. And that's it. So you basically wrote down in words what the picture showed you, what the diagram showed you. Okay, so you have your region of acceptance and rejection. Now let's work with step 3, which is your chi-squared statistic itself. So calculating your test statistic. Now this one is a little bit more work that's involved here. So for your chi-squared statistic itself, you have to draw up a table, and they generally do sometimes tell you how this table should look, meaning they do give you a head start and they'll say to you, draw up the following table, and they'll tell you what headings to include. However, you cannot guarantee that. So we do suggest that you study that and learn what the headings of the tables would be, because you can't guarantee that they will include it and you don't want to be in a position where you don't know what goes into the table. So the table is going to need 4 columns. Now, the calculation of the chi-squared statistic, there is a specific formula to it. And I'm going to write down the formula here. And this is actually done in the table. Now, let me write down the formula and I will show you and explain to you how it's done in the table. Okay, so firstly, the chi-squared. And remember I said to you earlier, this is the symbol that we use for chi. It is sort of like a capital letter X. It's just a symbol that we use, a scientific notation that we use. That's chi, and then it's squared, so literally chi-squared. Okay, so how is the chi-squared statistic calculated? You will see that it says it's the sum of, and then here you have a fraction that says FO minus FE, and it's squared, and then you have FE alone at the bottom. Now, what is FO and what is FE? So when it comes to your chi-squared distributions, you always have an observed frequency, which is FO. Again, this is all stuff you can read through in your slides. You have an observed frequency, and this is always the one that's given to you in the information. And then you have something called an expected frequency. And an expected frequency is what you will have to calculate. Now, in these tables, for example, this table here for the two-way table, and then even this table here at the bottom, the information in those tables are the observed frequencies, meaning this is the one that's always given to you. You then have to calculate the expected frequency, and this is where the table comes in. The table is where we calculate the expected frequency and we enter it into the table. And then in the formula, it says, as you can see, take the observed frequency minus the expected frequency and square it, and then it's over the expected frequency. Now, why I did not show you that formula earlier is because we're not actually going to work with the formula. We don't need the formula because if you look at this part here, just the fraction, it's the same as what you see in this table. And this is why I said I can only really show it to you when we're working with an example, because you need to be able to see how we put it into table format and how we calculate the values of FE and then use it to calculate the rest of the formula. So that part that I circled, as you can see, is done in the table itself. And then once you're done with calculating that, you simply add up that entire column, and that is then going to give you the sum of that you see here, and that is going to be your chi-squared statistic. So you actually don't need the formula at all because the formula is what is done in the table. So ultimately, you're calculating this fraction in the last column. And when you sum up that last column, you are now summing up that entire thing, that entire fraction, and that will give you your chi-squared statistic. Okay, so now let's look at the information. So as I said, in the table, you will always be given your observed frequency. Now let me show you how we enter information into the table. So firstly, when we enter information into the table, we're going to start with the first row of information, and we're going to work across the row, and then we'll move to the next row. Now, when we say across the row, we are ignoring the total columns for now. So don't worry about the total columns. It's only this information here. And we are starting with female. So I'm going to say female here at the top. And then it was momentum. Momentum. And that first value was 12, as you can see here. So we're going to write in 12 in line with FO. The next one was Liberty. So Liberty was 24. So you're going to put in 24 here. And then the next one was Discovery. Again, you're just going across. So Discovery was 61. Then you're done with the females now. You completed that row, so you move to the next row. So the next row now is your males. So you'll put in the heading of males, and then again go across. So momentum is 30, liberty is 48, and discovery is 125. And now you're done with your FO values. So you're literally just copying from the table for that one. And then you need to now calculate your respective FE values. Now, how do we calculate the respective FE values? So again, this is a little bit more work. So we're going to have to firstly, please pay attention to this one so you can see how this is done. And then we're going to have to use this formula. So it says take the row total, multiply it by the column total, and this is all in your slides as well, and divide it by the total sample size. Okay, so using this formula, we're going to start with, in the table, remember we started with female and momentum, we're going to start with the same value. So you're going to go to its row total, which is in line with it, the total of 97. So for example, it's 97 times, then its column total is coming down 42, and then it's divided by your total sample size, which is always the last value in the corner, in the bottom corner of the table, which is 300. So it's divided by 300. So that gives you a figure of 13.58. Leave these as two decimals, please. Don't change them unless they ask you specifically to round them off. And that is your first one. Then the next one, again, exactly the same idea. So the next one we went to was Liberty. So this is row total is 97, multiplied by its column total is 72, and it's divided by the sample size, which is 300. So basically the denominator never changes because it's always going to be the sample size, which in this case is 300. So this is now 23.28. Then you have, again, now let's move on to the next one. So for the next one, it is row total, that's a 61 here. Row total is 97. Column total is 186. So it's 97 times 186 and then divided by 300. And that's 60.14. And then we're done with the females. Now we can move on to the next one, your males. So move on to the next row. The row total is 203. The column total is 42. So 203 times 42 divided by your 300, that's 28.42. And then the next one is the 48 in the table. So this is going to be row total 203, column total 72. So 203 times 72 divided by 300, and that's 48.72. And then the last one is a row total of 203, column total is 186. And then divided by your sample size of 125.86. And you're done with your FE column. Okay, so it's always the row total multiplied by the total, the column total, and then divided by your sample size. Now for the last column, you're doing exactly what you see written in the heading of that column. You're taking the observed frequency. So for example, it's 12 minus its respective FE, so 13.58 squared, and then over the FE, which is 13.58. So this is going to be, again, two decimals, unless they tell you otherwise, it's going to be 0.18. So this is your FO minus FE squared over FE. So let me just remove that now and let's do the next one. Oh, sorry, I don't know why it's not erasing here. Oh gosh, I'm gonna leave that. Okay, so for the next one, it's 24 minus 23.28 squared over 23.28. And that is 0.02. Then the next one is 61 is FO. Its respective FE is 60.14. Then that's squared over 60.14, and that is 0.01. And then the next one is 30 minus 28.42 squared over 28.42. And that is 0.09. Then the next one is 48 minus 48.72 squared, again over 48.72, and that is 0.01. And the last one is 125 minus 125.86 squared over 125.86. And that is also 0.01. All right, so that is then how you calculate your FO minus FE squared over FE column, and all you're going to do now is add up that last column. So this is 0.32, and now we're done with step 3. So now all we need to do is in step 4, look at where does this 0.32 fall on your diagram. So on your diagram, 0.32 will naturally fall somewhere on the left, and this is immediately in your region of acceptance. So you then need to write out your conclusion. So I'm going to need to remove this for your conclusion. Okay, so for your conclusion, you're then going to say that immediately accept the null hypothesis, and then you need to elaborate. So this indicates that, or which indicates that, and go back to your null and alternate hypotheses. Your null is being accepted, so you are saying that what the null says is true. And the null is saying that there is no relationship between gender and the preferred insurance provider. So you'll say exactly that now, which indicates that there is no relationship between gender and the preferred insurance provider. Okay, and that is it. So it is a bit of work, as you can see, but once you practice this, you will find that it is quite repetitive. It's exactly the same thing over and over again. And let's look at that in the second question now. So the second question, the only difference is that instead of saying that in your null and alternate, there's no relationship and there is a relationship. Now it's based on equality. And the degrees of freedom would be calculated as n minus 1. But the rest of it is exactly the same. So let's have a look at that. It's actually easier than the one we just did because we don't have a two-way table here. So it's much quicker than the one we just did. So it says to you, the marketing manager of a soap manufacturing company wishes to know whether the 3 different hand soaps that they produce are equally popular. Please make note of that because we will come back to that just now. A random sample of 900 consumers were asked to choose their favorite from the 3 soaps, and the results were shown as follows. So you have the type of soaps, rose, lemon, and citronella, and then they say to you, using a 1% significance level, test whether the soaps are equally popular. So literally from the question again, you're able to write out your null and alternate hypotheses. And remember, the null, whenever it's a quality of proportions test, will always say that they are equal. So you will say here that the soaps are equally popular. Literally what the question was asking you to test And the alternate will just say literally the opposite, which is that the soaps are not equally popular. Okay, so literally just saying the opposite of each other. That's step one done. Now, to determine your region of acceptance and rejection, acceptance is everything less than and inclusive of that line, rejection is everything greater. Now, to determine the actual value of that critical limit, you're going to look at what A is. They said it's a 1% significance level, so it's going to be 0.01. And your degrees of freedom here, because it's not a two-way table, it's just n minus 1. And N here is just the number of categories. So there's three categories, rose, lemon, and citronella. So it's going to be 3 minus 1. And that is going to be 2. So it's actually the same critical limit that we used in the previous question, because this was also a degree of freedom of 2 and a level of significance of 0.01. So we're not going to skip to the table because we know that it's the same value of 9.210. So now to write that out in words, you will say, accept the null hypothesis if your chi-squared statistic is going to be less than or equal to 9.210, and your rejection region will be where? So reject the null hypothesis if the chi-squared statistic is greater than 9.210. All right, and that is your step 2 done. Now, step 3, which is to calculate your test statistic. This is actually so much simpler than the other one that we did just now. The two-way tables are generally the longer ones. The others are like quite straightforward, not as much work needed for it. And it's also not as many steps needed. So you have your category, FOFE, and then the FO minus FE squared over FE. So here you just have the categories of rose, lemon, and citronella. So from the table, remember, this will always be your FO values. So this is 320 for rose, 295 for lemon, and 285 for citronella. Now for the FE values. Remember I said to you at the top, that sentence that said that they are equally popular. This is what we use for FE. This is now saying that they are equally popular. So if there are 900 in total, 900 people in total that they have surveyed, and they had an equally popular opinion about each of them, all you're going to do is say 900 divided by the three options, because now they have an equal split between the three options. So if there were 4 options, it would be 900 divided by 4. If there were 7 options, it would be 900 divided by 7. However many options they had available to choose from that people could purchase, that would be your 900 split over that number. So this was split between 3 different types of soap. So it was equally popular amongst all 3 of them. So you just simply would take the 900 total and divide it by 3. So that tells you that FE is 300 for all of them. So whenever they say they are equally popular, all you have to do is take the total number of people that was surveyed and just divide it by the number of categories or options that you had. So this then would give you 300. And in your last column, you're doing the same thing that we did earlier. It's FO minus FE squared over FE. And that would give you 1.33. Then here it's 295 minus 300 squared over 300, and that would give you 0.08. And the last one would be 285 minus 300 squared over 300, and that would give you 0.75. So this then is going to give you, sorry, I just want to erase this on the side here. Okay, so this then is going to give you a total of 2.91 as your chi-squared statistic. Okay, so this we then look at, and I'm just going to change the color of the writing to show you where it falls. Oh, sorry, I think I wrote down the wrong number. It's 0. Sorry, this is supposed to be, I left out the 0 here. It's supposed to be 0. It's just not erasing. Okay, there we go. This is supposed to be 0.08. Sorry, not 0.83. And then this adds up to 2.16. Okay, so this then is 2.16 as your chi-squared statistic. And again, now, as I said, I'm just going to change the writing to show you that on the diagram, this would be on the left. So this is then clearly in your region of acceptance. So now to conclude, you're going to say accept the null hypothesis, which indicates that and now go to your null. If you're saying you accept the null, you're saying that the null is true. And if you're saying that the null is true, then you can literally write down what the null says. So it indicates that the soaps are equally popular. All right, and that is it. Any questions from your end? Sorry, I'm just reading the questions in the chat. Yes, Keenan, not too bad. It is quite repetitive, as you can see. First step always the same, just the wording can differ. Second step always the same. You always look for an A value and a degree of freedom, and then you go to table 3 to get to your critical limit. Always write it out in words. Your table stays the same. The table will never change. It just depends on whether your information was given to you in a two-way table that looked like this or a table that looked like this. And then you're always calculating the same things, FE, and then that FO minus FE squared over FE. And then once you have that, you just compare it to your region of acceptance and rejection, and you conclude. Yes, Audrey, definitely going through the past paper questions is exactly what you need. I will also be hosting an NSS session that is just going to be recorded though. So they're not working the same way that they used to work last year. It's basically the same as I did with your assignment 1 and 2. It's a pre recorded session. I'll be going through a past paper and just taking you through the typical questions you can expect. Honestly, if you look at 2024 and 2023's papers, they are exactly the type of questions that you can expect for your exam. And then there's also a master class that they will be hosting for this module. I did send out the announcement earlier. I'm not sure if you've had a look at it, but you will be able to also use whatever they have from that masterclass as preparation for your exam. But definitely, without a doubt, the past papers are exactly the type of questions that you can expect. The layout should be the same. And again, just don't forget about those choices. So you're not essentially learning all 9 learning units, you are learning whichever would be chosen from each one. But although I did explain that already before in one of the previous sessions, I also am going to just reiterate that again when I do the NSS session. When I record that for you, I will reiterate that, these are the sections, these are the choices, this is what you do have to learn, that's compulsory, and then these are the questions that have the options. So this is where you can sort of limit what you need to learn. But essentially, if you do select certain learning units, it's either 5.5 learning units that you'll need to learn or 6.5 learning units, just depending on what your choice is. Okay, so any other questions from anyone else? All right, so if there are no other questions, that's it for today. Thank you, everyone. Enjoy the rest of your evening. I will upload this recording as well. The questions that I went through are already up on ARC, and I will also be going through 2 more questions in next week's session. Thanks, everyone. Cheers.